and welcome guys. It's the 12th of September 2014. Now I want to give you a heads up on a sunspot region to watch, and you might be surprised I'm not going to tell you that that sunspot region is 2158, the one that prior to the most recent few days has ejected a X1.6 solar flare. It's not that one, it's 2157. And it's not just because it has a beta gamma with a delta configuration that I'm going to give you the heads up on that. It's because the amount of sunspots within that region are there. Let's just go in. Oh, the other thing you'll notice in this update is I've included the Carrington event sketch that was drawn from the eyewitness Carrington back in 1858, I think it was. But let's have a look at some of the statistics then on sunspot region 2157. So we're over at Solarham, and as you can see, sunspot region 2157, if we go across, we can see that the spot count is 34, so there's 34 spots within that sunspot region, and the region, as you can see, is beta gamma with a delta configuration. Now, why do I say that is more potentially a risk than sunspot 2158? Well, you can see there's less sunspots in that region, and it is only now beta gamma. If we look down at the the flare probabilities, we can see 2157. They're saying that there's only a 25% chance of an X-class flare, but there is more chance when we look at 2158 of a 40% chance of an X-class flare. I think they've got those figures wrong, and over the next few days we're going to see that. If it erupts within the next 12 hours, there's a potential for it to be geomagnetic, and therefore we could expect a solar storm. But why did I include then the Carrington event? Well, I just find it interesting that the look of 2157 when comparing it to the Carrington event one. Not only for that reason, it was the Carrington event that had a day before a large flare erupt off the sun that was geoeffective in the Earth's direction, and it was that enabled the second flare, which was, I think, probably an X20 or X40, I think it was, the Carrington event. So when you compare an X1.6, which we had only a couple of days ago, it really is minor in the scale of things. But it doesn't mean to say that 2157 does not have the capacity to eject such a strong flare. And if it did, I would believe, even if it was only an X20, half of the potential power of what the Carrington event had, which was an X40 I believe, it could severely do some damage. And why do I say that, even if it was only half the power of the Carrington event? Well, just simply because of the last 50 years we've noticed a magnetosphere weakening, so that could increase the solar storm with regards to damage, and therefore it wouldn't need to be an X40, it could simply be an X20. The other thing is the Ed Dames, Major Ed Dames, the guy who run that military program for that precog type predictions in the future, talks about first we get an over the bow shot, and then we get a direct hit. He seems to think it's to do with the solar flare, but it is also predicted that we are in a red zone, so to speak, where we are expecting a super solar flare. Some of you may remember the article from the Sun newspaper that I showed you around 2012, but let's just have a look at what Wikipedia have on that. So anyone can Wikipedia this, but it says states that studies have been shown that a solar storm of this magnitude occurring today would likely cause widespread problems for modern civilizations. I suppose it's because of the technological advancement and the reliant today's in computers and things like that. You know, pretty much everything is controlled by them, including aircraft. There is an estimated 12% of a similar event occurring between 2012 and 2022. It makes me question why they even give it a date, you know, or a range of 10 years where this event could happen when, you know, studying solar cycles. Was there something similar spotted around 1859 with regards to sunspot or solar activity that you know, would enable someone to forecast such a thing? But nevertheless, I agree with that statement, you know, with that paragraph. You know, if we did have a super flare similar or even half the power of the one that was recorded in 1859, then, you know, we could be looking at major changes that would affect our today and everyday civilization. Yeah, I just thought on that note I'd pull up the 400-year sunspot observations and see if we could spot anything around 1859 or 1860 that would give us an indication of you know, what they would be using as a trend. And the only thing that I can find, if we have a look on here, let me just change the marker so you get a better idea. Nope. Well, that'll do. We're about round about 1859, if that's 1850, so another 10 years. So here, and the only thing I can notice that there was, you know, I wouldn't say dramatic, but there was a noticeable change in the amount of sunspots. And if we compare that with most recent activity, we can see that at least since 1950s it's been on a gradual decline. However, I don't record any significant solar flares around the 1950s period. So does that mean then that this theory is probably flawed with regards to, you know, dramatic changes in the sunspot numbers? I don't know. I mean, nothing obvious points out to me with regards to sunspot numbers and the connection of large solar flares at those periods of times. So, you know, it'd be interesting to find out what they used to predict, you know, a time from 2012 to 2022 that we would be 12% likely to get, you know, a super flare event. But nevertheless, you know, when we look at you know, the sunspot region today, let's just go back to that. So my conclusion on this is that I would be more interested in looking at sunspot region 2157 for the reasons already stated, and not 2158 again for reasons, you know, already stated. Is it likely to produce an X-class in the next 28 to 48 hours? I think it is likely, as you know, I've already explained. Is it likely to be a Carrington event type of X-class flare, you know, up in the 20 to 40 scale? I really don't know. All I can say is let's watch this space and see what pans out of it. All I can say is, according to, you know, other solar physicists, they seem to think we're in the zone period of where such a solar flare or super flare could occur. So let's just wait and see how it pans out. So then, to round this video off then, guys, we might as well talk about what we've got inbound within the next few minutes according to UK or UTC time. We have a geomagnetic storm on the scale of 3, and that was produced from the X1.6 the other day. And what can we expect from that? Well, as you can see, power systems voltage corrections may be required, false alarms triggered on some protection devices. Then you've got the spacecraft operations, surface charging may occur on satellite components, drag may increase on low Earth orbit satellites, and corrections may be needed to orientation problems and other systems. Intermittent satellite navigation, low frequency radio navigation problems may occur. HF radio may be intermittent, and auroras may be seen as far low as Illinois and Oregon. And I checked that on Google Earth, and that's around 47 degrees longitude, so, or latitude. So if you're now, this is one of the things I was talking to someone about yesterday. That means, if we're at 52 degrees, then there is a possible chance that we might, here in the UK, see an aurora if Illinois and Oregon are around that longitude or latitude. So, guys, might as well round it off here, as opposed to babbling on for another half hour. Try not to let it ruin your day. Keep your eyes open on that sunspot region. And be safe, be prepared. There's nothing we can do about it if it does decide to let rip and throw another Carrington event super flare our way. All you can do is what you've already done already. If you're a prepper, you'll already be ready for such an event, and if not, may the grace of God be with you. And on that note, guys, I'll say what I usually do. Bye for now.